Okay, so we're just looking at proofs again about real numbers, and again there's a few techniques we're going to be looking at. So look, I'm not going to give you an exhaustive range, and again these sort of questions you can look up as well, but let's just go over a few of them. So I'm just going to do 4. So for instance, here's my 4 types I'm going to do. If a is even, then a squared is even. And then second one I'm going to reverse it. If a squared is even, comma, then a is even. If x is a multiple of 6, then x is a multiple of 2, and prove that no number can be odd and even. So I'm talking about real numbers. In the next one, there'll still be real numbers, but they'll be proving irrationalities. Okay, so looking at methods of proof, we've got direct proof, contradiction, contrapositive. There's other methods, but these are the ones we'll be using in these ones. Okay, so moving across. So if a is even, then a squared is even. And we can do this directly. Now we know that if a is even, then a can be expressed as a multiple of some other number. Okay, evenness is just defined as that. Just a reminder, if something's odd, we say it equals 2m plus 1. So just remember that for oddness, but we're going to do even, obviously. So we've got an even number, and we've defined it, and now we're going to square it. So therefore, a squared equals 2m squared, which is going to be 4m squared. That's pretty straightforward. And then 4 can be expressed as 2 times some other number. And once you've got a multiple of 2, then you've got an even number. So therefore it's true. Okay. So copy that, come across. Okay, so the next one we're going to do is one with the opposite and the contradiction. We're going to use contra positive. So when we're going to use the contra positive, by using opposite statements, once we prove the opposite, then we prove the original. Okay, so if we can prove the opposite, then we have proved the original. So the opposite is, so if n is odd, then n squared is odd. Okay, so with the contrapositive, we start from the back and work our way forward. So n will be equal to 2m plus 1. So n squared will be 2m plus 1 squared. So we've got 4m squared plus 4m plus 1. And then we've got 2 times 2m squared plus 2m plus 1. So now we've got 2 times something plus 1. Like that number's going to be an integer. So now we've got the expression 2 times something plus 1. So that means it's plus 1, therefore n squared is odd. Therefore, we have proved the contrapositive. And once we prove the contrapositive, therefore we have proved the original. So therefore, if a squared is even, then a is even. Okay, so again, there's just different techniques it needs to be aware of, and need to practice. Okay, so this one, if x is a multiple of 6, then x is a multiple of 2, and we'll just do this one with direct. Okay, so x is a multiple of 6, so we can say it's 6m. Okay, that means it's a multiple of 6, and then obviously 6 has a factor of 2, so now we've got 2 times 3m, so now we've got 2 times something, and once we've got 2 times something, it must be even. And therefore, x is a multiple of 2. Okay, as well as being a multiple of 6. Okay. Let's come across to the last one. Prove that there is no integer that is both odd and even. Again, the best way to do it is with a contradiction. So the contradiction is let there be an integer that is both odd and even. Okay, so we're going to say the opposite. Let's say there is an integer. So that means on one side we've got an even number, and on the other side we've got an odd number. Okay, so that's what we're going to prove is a contradiction. Now we can't use the same letter, so 2m and 2n, that's okay. And then what we're going to do is bring the 2 across to the other side. So we've got 2m minus 2n equals 1. And then factorise. And so where is the contradiction? Well, the left-hand side, because it's got a 2, is an even number. And the right-hand side is an odd number. And so the contradiction is the left-hand side can't equal the right-hand side, so there is no number. And even. Okay, so we'll try to find some more questions to practice on these type of examples. Okay, thanks, bye.